Hello, this is data modeling and remote control for networks and security course. This is Jeon Porjong. Today we'll study OpenStack based cloud systems. Cloud systems. So what is cloud system? Basically, cloud system is a cloud computing system lighting, processing data, and also sharing information in server space with internet-enabled devices such as a laptop, computer, and smartphone. So Microsoft Azure, AWS, okay. So the Amazon, the cloud, okay, service is called AWS, right? So the Azure case, cloud computing is delivery of computing services, including servers, storage databases, networking, software, analytics, and intelligence over the internet, called the cloud, to offer faster innovation, flexible resources, and economies of scale. On the other hand, AWS, okay. So cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as needed basis from a cloud provider. Okay, so in that case, don't need make local devices to handle those kinds of the video and the music like Melon in Korea, right? So remote server in cloud can be used to handle your multimedia data. Okay, so and then you can easily run your own business. So the type of cloud services, the on-site is just using your own server, and the EAS and the past SaaS case, EAS is infrastructure as a service, and the PaaS is a platform as a service, and SaaS is software as a service. Okay, so you can see we have the layers, so storage and networking storage server is computing, right? So virtualized using hypervisor, and then so upper we have a guest OS, and then middleware, runtime library, data, and application. So in that case, just up to virtualization layer used, it is called IaaS. PaaS case also up to runtime library. SaaS is all layers, including applications are used, like Google application, like Gmail or Google Drive, Microsoft Office, okay, 365, okay, etc. And then ESK is Amazon Web, okay, service, AWS, okay, and Azure, OpenStack. Usually open cloud service is EAS, and the platform is more higher service, AWS, Elastic Beanstalk, Google App Engine, something like that. Okay. So this figure shows different viewpoint, right? So data point, physical, some prices, and the networking security and the server storage. So this is called the infrastructure as a service. The PaaS case operating system for guest OS and other developing tool management for business, and the analysis case PaaS used. And the SaaS is up to application, right? So host application platform like Google applications. So virtualization is important in cloud computing. One of the most important feature cloud computing is the virtualization. So virtualization is the process of creating software-based entity that has a virtualized compute, storage, and networking resources using hypervisor. Okay, so there are two types of hypervisor: bare metal hypervisor and the hosted hypervisor. So this one, first one is a bare metal hypervisor. Okay, here the hosted. This is a hosted hypervisor, right? So you can see the hardware resources hypervisor virtualize the resources and then making guest OS virtual machine. So this is called the type 1. Type 2 case, the hardware, it has a host operating system, okay, and then hypervisor making a virtual machine with guest OS, okay. The most popular open source code based cloud computing source project is OpenStack, okay. So OpenStack is a cloud operating system to control a large pool of compute, storage, and network resources in a data center to provide the administrator with a dashboard, okay. So the web base is the dashboard for control, and to provide the user with a web interface for resource provisioning, okay. So this is OpenStack, bare metal, resources, servers, right, and the virtual machine, container, okay, using a Docker, and then the storage object file block types, and the dashboard using control this OpenStack, and then monitoring and other performance measurement tool is used. So OpenStack components, okay. The OpenStack platform is composed of multiple components called the project. So we have a lot of projects. So each project is managed by a technical committee, and the OpenStack Foundation decides which projects are ready to be included the OpenStack core. These projects work together to provide the services required to deliver the cloud services. New projects are being added with each release according to the demands of OpenStack community. So this figure shows a lot of OpenStack projects. Okay, so the web front and then this is work provisioning, application lifecycle management, orchestration, and the computing, resource management, storage resource management, networking resource management. Okay, especially Neutron is for networking, and hardware lifecycle management, bare metal management, and also left-hand side, the client tool integration enables tools project here. Right-hand side, the operations tooling like the monitoring service, resource optimization, billing, and business logic, testing, benchmarking tools. And bottom cycle management tools. Okay. So this figure shows a logical architecture. We have OpenStack users using GUI dashboard, and then you can see many OpenStack components are interconnected. Okay. So this is OpenStack some object. Okay, so container, account database, object database, and also here we have the hypervisor and also Nova. Okay, and the OpenStack computing node managed, and this is block-based storage, and this is a networking, right, using Neutron project. And this is Keystone for authentication. Okay, this security services project. Okay, so those are connected by OpenStack projects. So we have tables to explain OpenStack components. So the our alarming service and the Barbican key management Blazor is resource reservation for OpenStack, and cellometer for telemetry to monitor and meter OpenStack Cloud for billing, benchmarking, scalability, and statistical purposes. And Cinder block storage service. Glance is for image service. Okay, virtual machine image are managed, and HIT orchestration. Okay, services, and the Horizon for user dashboard service, web-based service, and the Keystone Identity provide the authentication and authorization service for security, and Mistral for workload. Okay, and the Neutron for networking. Okay, so enable network connectivity as a service for other OpenStack services. Okay, and the Nova is computing load management, and then Tecker for NFV orchestration. Okay, so provide NFV VNF manager and NFV orchestrator. Okay, to manage VNFs. Okay. So from now on, we'll see how to install OpenStack. Okay, in your machines. So the specification, at least the operating system Ubuntu this version. So you can install VM workstation or VirtualBox, and then you can install Ubuntu Linux. Okay, so RAM and storage and the CPU. So this is a minimum spec, and then multi-core CPU should be used. And then OpenStack installation. So installation is installed on a freshly installed Ubuntu 20 for desktop version using DevStack development. Okay, so installation step is as follows. Okay, so first step, update advanced package tool using sudo apt-get update, and then create a stack user, sudo user add. Okay, the stack user, and then echo this, echo, and then sudo su stack, and then thirdly download the source code from the GitHub link, OpenStack DevStack, and then go to DevStack portal and then create the local configuration file, local.conf, and then edit the local conf file with the file from this. Okay, so you can refer to our previous I2NSF interface to network security function framework. Okay, note, make sure to change the IP address according to your machine IP address in local.conf, and the run stack.share file. Okay, like this. Okay, and then pulse yes, and then stack shell is executed, and then it takes time from 45 minutes up to 1.5 hours. Okay, so and then this screen shows installation of your OpenStack. So dev stack component timing. Okay, and then your host IP address. Okay, and then you can see. Okay, and the OpenStack dashboard. Okay, so OpenStack provides users with a web-based user interface. Is called the Horizon project, accessible with a browser to control and manage OpenStack's services. Okay, to access the web-based user interface in OpenStack, you do the following steps. Firstly, open a web browser such as Google Chrome, okay, or Apple Safari, and secondly, type URL like http your IP address. Okay, slash dashboard. So IP address is your IP address. Okay, your Linux machine with the OpenStack, and then you can see OpenStack dashboard. Okay, so OpenStack provide this kinds of web page, okay, web-based user interface. This is a Horizon project accessible with the browser to control and manage OpenStack services, okay. So like instance management, image management, key pair management, okay. So this is instance name and IP address flavor, okay. Key pair status availability, the power state, the actions, okay. First of all, we needed to create a new virtual machine. So login to the OpenStack server with the secure shell SSH. For Windows user case, you can use PuTTY, okay, and then secure shell user, the actual user ID at the IP address for your OpenStack machine, and then okay, password user, okay. So like this, okay. So if user ID is a student ID key, is a secure shell, and the U is a prefix user, and the actual user ID following and the at IP address of the machine to connect. And secondly, create a file called the RC resource file and add the following authentication information, okay, touch RC. So and then here you can change student ID into your own student ID, okay. So here you can export the environment variable, so you can student ID is your student ID, okay. So set up password, authentication credentials. Now that Keystone is bootstrapped, okay. And thirdly, source the RC file using source command, and then create the public and the private keys for security, and then upload them to OpenStack. So first of all, you can make a key pair using SSH keygen RSA. This is a public private key asymmetric key, right, scheme for cloud key, okay. And then the OpenStack key pair create the public key, okay, and the cloud key, okay. So you can see this is a command, okay. So this command is performed, okay, in generating public private RSA key pair, okay, and then you can make RSA key pairs, okay. The fifthly, check the networks key pairs flavor and the images in the OpenStack. So using 4 commands, check the image, network key pair, flavor, okay. These data, okay, will be used to create the virtual machines, okay. Sixthly, create the 2 virtual machines. One is for Mininet, the other one is OpenStack using image network flavor and key pair data from the previous slide, okay. So Nova put image, okay, using this net ID flavor, key name, cloud key, OpenStack you install, and the next one is you install, okay, Mininet, okay. Seventhly, check the virtual machine's status is until it is active, okay. So OpenStack server list. So we can see Mininet, OpenStack are active. Eighthly, create 2 floating IP addresses, okay. So you make other IP addresses for Mininet and OpenStack, okay, using this command. And then attach the floating IP addresses to the virtual machine, okay. So you can make pair, okay. Mininet has this IP address, OpenStack has this IP address, okay. And tenthly, check whether the floating IP addresses are successfully attached or not. So using OpenStack server list, we can see Mininet and OpenStack have this floating IP addresses respectively. 11 step Okay. Add the security group policy to allow SSH to access a virtual machine. Okay, so security group, and then this kind of command we can allow. Okay, SSH shell can access those two virtual machines. And then 12th step, to connect to both virtual machines, you need two terminals. The first one, SSH connection to Mininet. The other one is OpenStack. Okay. Okay. And then on the next step, 13, on the two terminals, SSH to different virtual machines. Okay. One is for OpenStack virtual machine. The other one is Mininet virtual machine. So SSH, cloud key, and then Ubuntu, and this, okay, IP address, floating IP address for Mininet. This one is OpenStack, okay. And then you can see the right snapshot. So this is from this one for Mininet. This one is for OpenStack, okay. So 14, refer to the installation step in the OpenStack and Mininet class, okay, to install OpenStack and Mininet in the virtual machines, okay, because we made virtual machines for OpenStack and the Mininet. In conclusion, in this class we learned the following: first, cloud computing; second, OpenStack tutorial. Also, virtualization using OpenStack as the clouding system. Okay. Also, we saw how to install OpenStack in your machine, and also we learned how to set up SDN emulation with OpenStack along with the OpenStack and the Mininet. If you have a question, please let me know. Thank you for your attention.